Hello and welcome back to another episode of Math with Stone. Today, we're going to be solving some systems of inequalities by graphing because that's pretty much the only way you can truly solve it. So, it is known, hopefully, that if it has a bar underneath, that indicates that it is equal to as well, and anytime it is greater than or equal to or less than or equal to, you got a solid line, versus if it's just greater than or if it's just less than, then you got a dotted line. And typically, greater than you shade up and less than you shade down, but there's some limitations to that. So here's our first example. We got y is greater than 2x minus 3. So we're going to plot the y-intercept at negative 1, 2, 3. And then we have to go up by 2 and over by 1. And we got to be careful because it doesn't have an equal to symbol on here. This is going to be a dotted line or a dashed line, both of which are acceptable. So there we go there. I do not want to color it in. The next one we have negative 3 over 4x plus 2. So it has a y-intercept of 2. And then we're going down by 3 and over by 4. Down by 3, 1, 2, 3, over by 1, 2, 3, 4. And this one, because it has the equal to symbol, it will get a solid line. And because we have a system of inequalities here, we have to shade appropriately. Now, sometimes they say plug in a test point, like plug in 0, 0, and see if it works. I like, as long as it's in y equals mx plus b, thinking of where would you fall off the mountain or where could you climb the mountain. So starting with this line right here, which I have in dotted, it would need to be greater than, so I'm going to shade up. So everything above that dotted line would be where you could climb the mountain, so everything up here. And then for the other one, it is solid, and this one is less than or equal to, so in this case, I need to shade below the solid line, and I like shading in a way where it gets a crisscross pattern, so wherever it crisscrossed would be where it overlaps, and this would be where the actual solution is to the system of inequalities. Okay? So, next problem, we have to solve for y. You could use the x and y intercepts, but then it makes it more difficult to know which way you're actually shading. So I would recommend solving for y by subtracting x from both sides. You get 4y is greater than or equal to negative x minus 12. And then divide both things by 4. If we divide everything individually by 4, you get y is greater than or equal to negative 1 over 4x minus 3. So let's graph that. We got a y-intercept of negative 3, 1, 2, 3. And this time it has an equal to symbol underneath, so we're going to go solid line, but we have to go down 1 over by 1, 2, 3, 4. 1, 2, 3, 4. Okay, and then you could backtrack it up by 1 over by 1, 2, 3, 4 if you wanted to. It's a solid line, and I'm going to shade right away. So I'm going to graph it, and I'm going to shade it right away. It's greater than, so everything above this line. So I'm going to kind of lightly shade everything above this line in this kind of general direction. Now the other equation, we have to also solve for y, and we need to be careful because it incorporates one of the things with inequalities that is just a thing. When you divide by a negative or multiply by a negative, like we're doing here when we divide by negative 2, we have to flip the inequality symbol. So here, we got y is now going to be greater than or equal to positive 3 over 2x. We flipped from less than to greater than. Negative divided by negative made positive 3 over 2. And then plus 0.5 or 1/2. So we got to graph that. So we got 0.5 as the y-intercept. A little annoying, but it's fine. And now we have to go up by 3. So up by 3, we're going to count half increments. So here would be up 1, 2, 3, and then over by 2, 1, 2. So we have our slope. It is also a solid line because it has the equal to symbol underneath. And there's our line. Which way should we shade for this one? This one is also greater than, so we have to shade above the line. So this area right here would be where they would overlap. All right. We have our last generic example, but this time it has 3 equations. So when it has 3 equations, first off, you're going to need to find the overlap of all 3, if it exists. Not all the time it will. So x is greater than negative 3. You find the vertical line at negative 3, and in this case, it is less than, greater than, not equal to. So it is going to be a solid, not a solid, but a dashed or dotted line. And it needs to be to the right of the negative 3. Uh-oh, I did positive 3. So, whoops, ignore that. Positive 3 is over here. Negative 3 is over here, and it would need to be to the right of all of that. All right, luckily it was dashed. The next one is greater than x minus 1, so it has a y-intercept of negative 1 and a slope of up 1 over 1, up 1 over 1, up 1 over 1. I'm doing a dotted line the whole way. That way, I don't have to dash it or anything else. I'm just mimicking the slope here, making it more accurate. And in this case, we have to shade up because it is greater than. So everything up here. Currently, my overlap is this area up at the top. All right, currently that is the overlap, and let's see if I have a different color for the third line. We have less than 1 over 3x. That x over 3, that is no different than saying 1 over 3x. So the slope is negative 1/3 with a y-intercept of positive 1. 1, 2, 3. It is getting a little hard to read. And then we go down 1 over by 3. Down 1 over by 3. And this one would be a solid line right here, and we would be shading down. So if we shade down, in this case, the overlap would be where all three are intersecting, and that would be that chunk in the middle. Not all the time will you get the chunk in the middle for those, so don't just assume it's going to be where the middle part is. So shade and find the actual answer. Write a system given a graph. So in this case, we gotta squint because the graph is hard to see. We have a line up here, this horizontal line right here. We have this dotted line right here. And I think that's all we have, those two, on our equation. Unless I'm missing one. I think we got a third one. I gotta find it though. Where is it? I can't see it. So we're going to go with those two. There is a third one somewhere, or it's just messing with my eyes. This one, it looks like we are at, I'm going to go with y equals 2 type of line because it is horizontal. It's a y equals line. And it's shading down, so I'm going to say y is less than or equal to 2 for that line right here. This one's less than or equal to 2. What about this one? Well, this one we are shading above the line because you can kind of see that they're shading up here. And with that being said, it is going to be a y-intercept of 5, and it looks like it is going, hard to read, it looks like it is going down by 1, 2, and over by 1. So we are going to go y is greater than down by 2 over by 1, so negative 2 over 1x. Plus 5, and we're going to scribble that one out. And there might be a third line, but I honestly cannot see it for the life of me. I would need to look at my digital file, which is on a different computer, so I apologize. But that looks like where it's at, right here, where these two are overlapping as such. Okay? Now we got a word problem for you. Word problem. We got a movie theater. It has approximately 400 seats. I was guessing. It might have more, might have less. But this particular movie theater has 400 seats. The box office has a goal of making $2,500 on any given movie being shown at this movie theater. Okay? So a child ticket costs $5, an adult ticket costs $10. I picked two numbers that were, roughly about the same. Write a system of inequalities to represent the scenario. So the first thing you got to realize is that we have at most 400 seats. We can sell all 400. So if we put together the adults and the kids, or the childs together, they cannot be any more than 400. They can equal 400, but the adults and the kids put together has to be less than or equal to 400. It cannot be greater than the 400. All right? Well, what else do we have? We have $5 per kid, per adult, and $10 per, I don't know what I just said. $5 per child, $10 per adult. So if we do $10 per adult and $5 per child, they want to have that number be more than or equal to $2,500. I feel like they'd be okay if they got $2,500. So these two put together have to be greater than or equal to $2,500 if the movie theater wants to make their money. All right. Now it says sketch a graph of this scenario. In order to sketch a graph of this scenario, I am going to use the intercept method because it's in standard form and this graph is only like a 7 by 7, so I'm going to have to fake it. So we have A plus C is less than or equal to 400. I am going to label my adults here and my children there. So I'm going to call A my Y value. So that means if we use the cover-up method, the solving and finding the intercepts, my A intercept and my C intercept are both going to have to be at 400 for this first one. So for the first one, we have, for the first equation, A plus C less than or equal to 400. Our A intercept would equal 400, and our C intercept would equal 400. All right, perfect. I'm going to wait to fill them in because I don't know what's going to happen with the other equation. With the 10A plus 5C is equal to 2,500, well, excuse me, greater than or equal to that. The intercepts there, if we divide 2,500 by 10, you get 250, I believe. 2,500 divided by 10, you get 250. So the A intercept there would be 250. The C intercept there would be 2,500 divided by 5 would be 500. Okay, so I need to start and recognize the reason I did all four of those first is that I wanted to know the scale of this graph. And now I know that the most it can possibly be is 500 for a child. And when it was 500 for a child, it was 250 for an adult. So that would be at the perfect middle. We got 1, 2, 3, 4, 5, 6, 7. So around here would be 250. And if I graph that, I have that line right there. Now in the other equation, it was 400 and 400, which I'm just going to call here and here, approximately. And it'd be this right here. And both of these were greater than, so both of these, this one was less than, the black line was less than, so it would have to be smaller than that one, but greater than the other one. So we're looking at this little sliver right here of acceptability, right there where it was greater than one, but smaller than the other. Okay, so there is some scenarios where this theater does make money. What is the minimum number of adult and child tickets the minimum number of adult tickets, not child tickets, that the box office would need to sell to reach a goal of 2,500. I don't want a number of adult or child tickets. I just want the minimum number of tickets. Minimum number of tickets the box office needs to sell to reach a goal of 2,500. So if we want to know the minimum number of tickets, we have to think, what would be better for the movie theater? To sell adult tickets or to sell child tickets? Well, they would want to maximize how many adult tickets they could sell. So what if they sold all adults? If they sold all adults, how many would they need? How many adult tickets would they need to reach 2,500? Well, let's see. What's 2,500 divided by 10? That would be 250 adult tickets. So that would be the absolute minimum amount of tickets that they could sell to reach their goal of 2,500. Their maximum number of tickets they could sell to maybe reach the 2,500 would be the worst case scenario is they have a whole bunch of children in there, which I don't even know if they could fill that out. Because if we had all children, it'd be 500 tickets. They cannot sell all children tickets. So thank goodness we have adults in the theater too. And then the last one for today, if the box office sold 100 child tickets and 100 adult tickets, would they reach their goal of 2,500? Well, let's see. 100 child, 100 times 5, plus 100 times 10. What does that equal? Well, 100 times 5 is 500, and 100 times 10 is 1,000. If you put those together, you get 1,500. No, they only made $1,500, which is less than $2,500. That's going to do it for this one, everybody. Until next time, stay positive, my friends, and I will see y'all later. Bye.